Hello students, and welcome to another video on domain and range. And I actually think this video is going to be even more helpful than my first video. I have a series of graphs. I think there's 12 total here. Yep, 12 or 13, I'm sorry, 13. And each one of them is going to help us to interpret domain and range a little bit better. So let's just get into it. Let's look at number one. And I apologize for the numbers being underneath here. I couldn't get Word to format this the way I wanted to, so we'll just go with it. So let's take a look at number one. As you can see, number one, it's sort of just a sprinkling of different ordered pairs. There's really no connectivity to these dots. They're just kind of sitting here on the XY plane. This is probably one of the easiest domain range problems to interpret. What I like to do when we just have dots like this is I like to sort of make a table, and I can do this off to the side. And I like to list out all my different ordered pairs that I'm given. So you can see, like right here, this guy down here is located at -3, -4. So I'll write that as x -3, y -4. And then maybe I come up to this guy here. He looks like he's at -2, 5. So -2, 5. And then this guy right here is at 1, -2. And the one on top here is at 1, 3. And this guy out to the right looks to be at 4, 0. So this is what's so great about this table. We know domain are the values of x from our graph. So I'm just going to pull the x's from the table, and I'm going to list them out here as my domain. If I want to go from lowest to highest, I would have a -3, a -2, a 1, and a 4. Now notice I'm only writing the one time as opposed to twice, because you can see 1 is in my domain and you don't have to repeat it. We know there's an x value of 1 on our graph. And as for the range, I'm going to grab the y value. So from least to greatest, it looks like -4, -2, and then 0, 3, and 5. So that's pretty simple. And this is if you're given just a splash of dots. Let's see if there are any other ones like this on this worksheet. I don't see any more on the front side. Okay, number 8. If you turn to the second page, number 8 is a sprinkling of dots, much like number 1. So let's do this one. I want to kind of do all the ones that are similar right off the bat. So I'm going to make that XY table. I like to work from left to right. So my first order pair right here would be -3, 1. Or is that -4, 1? 1, 2, no, -3, 1. I apologize for these small graphs. And then this guy right here would be -2, 0. And then I have 1, 1, 2, 3, 1, 4. And down here I have a 2 and 1, 2, 3, 4, 5. So 2, -5. And then here I've got 5, 1. So here is my domain. And it looks like it's already ordered from least to greatest. So -3, -2, 1, 2, and 5. And my range from least to greatest would be a -5, and then a 0, and then a 1, and a 4. And again, 1 repeats itself, but I'm only going to write it one time. Okay, let's keep looking. Any more like that? Yes, number 12 on the final page, another sprinkling. So let me make that table. So looks like we've got -3, 1, -3, 1, 2, 3, 4, -4, 1, 1, 1, 2, 3, 4, 5, 1, 5. Again, apologize for my bad eyes here. 4, 0. And 5, 1. So again, domain, range. I'm not going to repeat -3 twice. I'll just write it once. So -3, 1, 4, and 5 for my domain, or my x. My range in order would be -4, 0, 1. I'll just write that once, and 5. So hopefully that's enough for you to understand pretty well how to do domain and range when you just have some dots. Okay, now how do you do domain and range when there's more connectivity? Let me just go right here to number 13. I love this one because number 13 is just this little box here, and it will be very simple to demonstrate how you do domain and range on a shape like this. So let's set it up, domain and range. Now I'm going to use some terminology here. I'm going to say set the template. I'm going to write that down. Set the template. I use this with my students in class. I'm going to use it with you now. What I mean by set the template is when you're doing domain, you darn well know that's X. And when you're doing the range, you know it's Y. And from earlier work in this course, we know that when we want to state that X is between two numbers, we do this notation here. We sandwich the X with two inequality signs pointed left like this. This is going to say X is greater than this number, but less than this number. So whatever I put here and here, X will be, because if I cover this up, see this says X is greater. See how the mouth is open toward the X? X is greater than this number and less than this number. So what it does is it puts X between these two. Same thing for the Y. Y is going to be greater than this number, but less than this number. So when I say set the template, this is what I'm talking about. This is for every single problem that you're doing domain and range for. Okay, so now what I like to tell students, domain works on the x-axis. The x-axis works left to right. And the y-axis, that does not work left and right. The y-axis works down and up. So left to right, down to up. Now watch how easy this template makes domain and range. So you look at your graph and you say, well, how far left does my graph go? Okay, well, isn't that right here? This is the leftmost part of the graph. My graph goes this far on the x-axis to the left, and that is situated at 1, 2, 3, 4, -4. And how far right does my graph go? How far to the right is this picture? How far right on the x-axis? Well, 1, 2, 3, 4, +4. So let's think about this. So my x's are between -4 and 4. And if you look at this, look at the x's. They most certainly are between -4 and 4, no matter where you go here. -4 to +4, left to right. And more than that, because everything is solid and filled in, I can include -4. I do have x's at -4. And I do have x's at +4. So I'm going to make these less than or equal to symbols. Cool. Now the y. Down to up, bottom to top. So how far down does my graph go? Well, that looks like 1, 2, 3, -3. And how far up does my graph go? 1, 2, 3, 4. Is that a 5? 1, 2, 3, 4, 5. Yeah, 5. So -3 to 5. And so you can see my y values are everywhere between bottom to top. -3 to 5 inclusive, because you have values at -3 and you have y values at 5. Isn't that cool? It's so easy. Let's see if we have any other shapes like that. Let's go back to the beginning. Oh yeah, we've got a couple shapes. We got this one and this one here on the front. So let's look at number 2. Let's set the template. Set the template. X, Y, push left, push left, push left, push left. That's the template. Let's set it up for number 3 as well. Domain, range, set the template. X between, Y between. Perfect. Okay, so let's go. Left, right, down, up. So how far left does this graph go? Well, if you look at this picture, right here is the furthest left that the graph goes, and that's -3. Okay, how far right does it go? Well, this is the furthest to the right it goes, and that's at +3. They are both closed dots. Fill it in. How far down does my graph go? Boom, -4. How far up does it go? 3. No open dots, close them in, you're done. So that was left, right, down, up. Let's do the next one, the circle. Cool. Here we go. X, left to right. How far left? I would say right there is the furthest left this circle goes, and that's at -2. How far right? +2. Close in. How far down? 0. How far up? 4. Close it in. Done. Simple. Left, right, down, up. Now these two I'm going to save because these are not closed in pictures. These have arrows. Arrows mean something different. We talked about that the other day. We'll save those. Okay, let's find more closed in pictures. Ooh, here's another circle. Let's do this circle. Domain range. Set the template. Bing, 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 bing. Let's go left, right, down, up, left. Okay, right here's the furthest left we go. And that is at -2. How far right? On the X now I'm talking, +2. Close it in. How far down? That's right here. That's at 1. How far up? 5. Close, close. And you can see the X's are between -2 and 2. And the Y's are between 1 and 5. See that? That's where my X's and Y's are. Okay. Any more sort of closed in pictures like that? Yeah, this triangle right here. So we set the template. X between, Y between. Okay, left. This is how far left we go. The furthest left we go is -3. The furthest right we go is the tip right here, that point, and that's located at +3. Close it. How far down do we go?
Connie Cook, please call extension 1082. Thank you.
This is how far down we go, so that's 1, 2, -2. And how far up we go, you might be thinking it's here, but it's actually this point. This goes higher. So the highest up we go is 4. If you're having trouble with this one, you could always do this. Sometimes this is helpful. If you kind of take your shape and like box it in here, sometimes this helps. So you can see if you box this shape in, you can now see furthest left is right here on this line segment. Here's your furthest right, and then down to up, bottom to top, tippy top. All right, excellent. Okay, so what do we have left? Well, maybe we could talk about these lines now. We learned this one the other day. I'm not sure if you remember it or not, but here's the deal. When you're doing the domain and range, you still set the template. Set it, set it. Here's the thing though. You may try to box this in. Look, if I try to box this in to determine how far left and right I go, I might be like, cool, I got this. Like, okay, so this shape right here, it goes, I don't know, like it goes far left as -4 and as far right as 5. So maybe I'll put -4 to 5, and then like it goes down to -6 and up to 4. So I'll put -6 and 4. But then I go like this. And I take it outside the box because that's what those arrows mean. And then maybe you try to box this in. And you try to set the template left to right, bottom to top. And then I go like this. And I keep extending and extending and extending and extending. And so X grows and Y grows. And so there's no end to the growth. So basically, the furthest left this graph is going to go, we talked about this, is -infinity. That's the idea of growing to the left with no boundary. It's just going to keep going and 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 going. Because at the same time this line is going down, it's going left, left and down, left and down, left and down. And it's going right and up, right and up, right and up. It's going to keep going. So the furthest right this graph is going to go is +infinity. It's going to grow, 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 grow with no bound. I do not want to put equal to signs on here because I'm never going to reach infinity. I can grow toward it, but I cannot reach it. So do not put equal signs on here. And we did talk about this before, so that should be pretty easy. Same thing with the y's. How far down does this graph go? Forever and ever and ever and ever. Negative infinity. How far up does it go? Forever and ever and ever. Positive infinity. So we learned that whenever you have a diagonal line, a linear equation that's neither horizontal nor vertical, but diagonal, and arrows on both ends, this is always going to be your domain and range. Now, number 5 is sort of a twist on that. It's similar in that it has arrows, but there is a slight difference. So let's look at this V shape. Let's set the template first. Love that. Makes it so easy. Let's kind of box it in. So like if I'm looking where I am right now, it would kind of do this. If I try to box this in from the start. So maybe you say, okay, left to right. Well, I go to like -6 and 6. So maybe it's -6 to 6. But then I do this for you and I say, well, not really. Now I'm out wider. And if I go again, my x's just stretched wider. So it looks like the x's are coming out negative infinity to infinity. But here's the twist. The y values, because of the turning here that creates this V shape, the lowest the graph goes is -5. And this graph is never going to go any lower than that. Like you don't see anything down here. So the lowest is -5, but the highest the graph goes is forever. So we'll put an infinity on there. So this is almost like this one. But the twist is this guy right here. Okay? And then we flip it. We're almost done, I promise. If you look at number 7 here, the horizontal line, kind of similar. Let's look at it. Domain range, set the template. Oh, wait, did I make a mistake here? Hold up. Go back. Oh, yes, I did. I just thought of it. On the -5, I hope you caught me. I should have an equal to, because it's not an infinity, and there is a y value of -5 on this graph. So let's close it in. Okay, back to the horizontal line. Here we are. Okay, so where's the domain? Well, let's look at this horizontal line. How far left does it go? Forever. Negative infinity. Whoa, negative infinity. Sorry about that one. And how far right does it go? Positive infinity. The arrows indicate forever, both directions. Now the range. How far down does it go? Well, down, there is no down. How far up does it go? Well, there is no up. It's just right here. So the furthest down it goes is 3. The furthest up it goes is 3. So the y is 3. So maybe we write it like this. The only y value on the graph is 3. No matter where you go left and right on this line, your y value is always 3. So your range is 3. And again, we did talk about this the other day. I'm just trying to kind of like give you a little more oomph with this domain and range business. Okay, so I think we only have, what do we got left? These two. That's it. Okay, so we got 6 and 10. Here we go. Set the template. Domain, range, x, y. Okay, let's check out this graph. How far left does it go? Well, kind of thinking right here. This is how far left it goes, and that little hole is at -1, 2, 3, 4, -5. How far to the right does it go? 1, 2, 3, 4, 5. Now, here's the difference here. This is an open circle, so it does not quite reach -5. I'm going to leave that open, but this circle is closed, so I'm going to include the 5 in my domain. Okay, how low does it go? How far down does this graph go? Well, this dot right here is the lowest. So is this open circle. See, they meet. They're both down at -2, but I'm going to close it because of this one being filled in. Even though this one's open, this is part of the range. This is a y value on the graph, so I'll include the -2. And how far up does the graph go? How high does it go? +2. And we'll include that as well. That's a filled in dot. And last but not least, this sort of sideways W shape. Let's set the template. And we go left. How far left does it go? Well, here's one left point, but I think this guy right here goes a little bit further left. He does. He's at -4. And he's filled in, so include. How far right do we go? Well, if I compare, I think this dot right here is the furthest to the right we go. So we went that far left, and we're going this far right, and that's at 3. But it is open. It's an open dot, so I'll leave this open. Okay, how far down do I go? This open circle is the lowest I go on the graph. That's situated at -5. It's open, so I'll leave this open. How far up does my graph go? Looks like this is +5. I'm also going to leave that open because the circle's open. Okay, so that was kind of a long one, but I think it was necessary. This gives us a wide array of different kinds of graphs. Domain and range can be a little bit confusing because it changes with every problem, but I tried to give you a nice wide assortment, so hopefully this helped to solidify the concept of domain and range. Thanks for watching.